This is a review of how to find an area of a non-right triangle. Acute or obtuse doesn't matter. In this case we have two sides, A and C, and the angle in between. So this would be a side angle side triangle situation. No opposite pairs, which is perfect for the area formulas. The area formulas are either A equals, basically 1/2 base times height is the basics, but 1/2 AB and sine of the other angle gamma, or it could be 1/2 BC sine of the missing alpha, or it could be 1/2 and sine keep the pattern, AC sine beta. Now what's important about setting these up is 1/2 base times height, don't forget the 1/2, and we have two sides, and the angle of the other side. So A and B are represented, and the opposite of C. BC opposite of A, AC opposite of B. Said in another way, you will never have a beta and a B in the same area formula, or an A and an alpha. They're all three represented, and don't forget the 1/2. In our case, we're going to be needing the one with beta, so we're going to be working with this one, beta. So we have A equaling 1/2 AC sine beta, and this is 1/2 36.2 is A, 45.7 is C, and sine of 60.8 degrees for beta. We'll go to our calculator, make sure you are in degree mode, and you get A equals 722.0549, so we will go to one decimal, 722.1. And I'm going to write units squared. The reason why I'm writing units squared is just as a reminder, if this had been A equals feet, 36.2 feet and 45.7 feet, then this would be square feet, or inches, square inches. The reason why we get the square part is A is the whatever unit, and C is that unit, and so A times C will be unit times unit, or square units. The answer in the back on this problem doesn't have any, but the next one will have square feet. So just make sure you understand this is an area, so it's a square unit. Find the area of the region. We are given four-sided shape, all different angles, all different sides, and we know how to find the area of triangles. So we're going to divide this in some way to make two triangles. It doesn't really matter how we do it, but we're going to draw a diagonal. So this is really two problems in one. Our first problem is this shape, where we have 2.94, 4.14, and the angle between 108 degrees. The area will be 1/2 one base. If we call this, well, it doesn't matter, 4.14 and 2.94, and sine of the angle in between. This gives us 5.79 square feet, rounded to two decimal places. Why the square feet is because we have feet times feet, and that'll be square feet. So this is A1. A1. Beautiful. We now need to find A2, and it's a very similar process. Let's get a little more room. Okay, A2 is going to be 1/2 side, 2.81, side, 4.80, angle between, sine 95 degrees. The formula for area is always this form. It's side, angle, side. So you use two sides and sine of the angle in between, and don't forget your 1/2. And also feet and feet to get square feet. So when we multiply these together, we get A2 equals 6.72 square feet, rounded to the nearest hundredth. and I'm going to the nearest hundredth because of the units are all the nearest hundredth for the sides. And now our final answer is just A1 plus A2 is the full area of this shape. So we have area equals 5.79 plus 6.72, all square feet. That adds up to 12.51 square feet, which is our final answer. Find the area of the triangle using Heron's formula, round to the nearest unit. The proof of Heron's formula is a whole bunch of algebra, and it comes up with a really nice formula. The pro of the formula is it's easy. The con is you have to remember a formula. The next problem, I will solve the same type of problem given 3 sides without this formula, so I can show you both techniques. Heron's formula is A equals square root S times S minus A times S minus B times S minus C, where S is the semi-perimeter, that is the perimeter, A plus B plus C, divided by 2, semi being like semicircle, half a circle, semi-perimeter, half a perimeter. So we first work out S, then we plug it in here and plug A, B, and C in and just solve it. It's just a formula now. So we get S equals 52.9, I don't want that parenthesis yet, plus B 65.4 plus 36.4 divided by 2. That gives us S equals 77.35. We don't know if these are units or anything, what kind of units, feet, inches. This would be whatever feet, inches the original A, B, and C were. Now that we have S, we now work the formula A. And a little more room. There we go. So A equals the square root of S, 77.35, times S minus A, 77.35 minus 52.9, and S, 77.35 minus B, 65.4, and S, 77.35 minus 36.4. And calculator. Now if you are careful with your calculator, you can either store this or just have it on your screen like my calculator is now and keep using the answer button. It's a nice way to go. So mine would look like square root answer, parenthesis, answer minus 52.9, parenthesis, answer minus, etc. You could also store and recall it each time. So this gives us A equals 962.01, rounded to the nearest unit would be 962. Now again, if we knew this was feet or inches, then this would be feet squared or inches squared. You can write units squared. Some teachers will want to see that. The answer key actually doesn't have any unit squared, it just has 962. Alright. Find the area of the triangle. If necessary, round the answer to 2 decimal places. This is like the previous problem. We have 3 sides. So we've seen how to find the area using Heron's formula. However, we can use the regular formula as well. For example, we could find the area with A equals 1/2. The first one, AB, sine gamma. This would be easy if we had gamma. We don't have gamma. We don't have any angles, or else we'd be using this formula. But law of cosines will find us this angle. So we go after law of cosines. Cosine gamma equals, that'll be the one with a minus c squared. So a squared plus b squared minus c squared over 2ab. Keep a parenthesis around the numerator and around the denominator and just plug a, b, and c into your formula and you get 0.9125. Make sure you're using this for A, this for B and this for C. Opposite pairs. Opposite of gamma is C. Opposite of alpha is A. Opposite of beta is B. Now, taking arc cosine of this answer gives us gamma. And we get gamma equals 24.1468, etc., 7. I'm not going to use just this approximation, though. I'm going to use the answer. So now I can do A equals 1/2 AB sine gamma. So capital A, area, equals 1/2 lowercase a, lowercase b, sine gamma. So that would be 1/2 A is 8 times B is 5 times sine gamma, which is the answer. I'll put a little arrow down to it. And we get 8.18, rounded to the nearest 2 decimal places as the instructions called out. So A equals 8.18. And no units, this would be another unit squared kind of answer. Feet squared, inches squared, centimeters squared. Make sure you have the appropriate unit if they give that to you. If not, I would still write unit squared so that it shows you that you were working with area. Alright, this is how you find the area of a triangle with 3 sides without Heron's formula.